Hey guys, I'm going to be going over the release of hormones via the posterior and anterior pituitary gland and how they specifically interact with the hypothalamus and how they communicate. So in my first slide, I'm just going to talk a little bit about the posterior pituitary gland and its anatomy. The posterior pituitary gland is two different glands that kind of merge together during development. And the two glands that merge together end up being the posterior and anterior pituitary gland. The posterior pituitary gland is a downward extension of the brain's neural tissue, and it maintains a neural connection with the hypothalamus. The anterior pituitary, however, does not have a direct neural connection between itself and the hypothalamus. However, it's instead connected, has a vascular connection, and it is completely composed of glandular tissue. So if you look to the picture to the right, you can see that the posterior pituitary is depicted in yellow, and it looks exactly like a downward extension of the brain. And then the anterior pituitary does not have that, neural connection with the brain. So, like I said before, the posterior pituitary is an extension of the neural tissue of the brain. However, it does not manufacture hormones, and it simply just stores them and releases them when the receptors, when the neurons are fired. This kind of works through an action potential. So action potentials travel down the axons of the hypothalamic neurons, causing release from their axon terminals in the pituitary gland. The hypothalamic hypophyseal tract is a nerve bundle that maintains that neural connection between the hypothalamus and the pituitary gland. So, instead of drawing a picture, I decided to kind of do a flow chart to depict how it goes from the hypothalamus to the hormones being released. So the first thing that it goes over is that neurosecretory cells either in the hypothalamus produce oxytocin or vasopressin. And these neurosecretory cells are paraventricular or supraoptic nuclei in the hypothalamus. Paraventricular specifically produce oxytocin, and the supraoptic specifically make vasopressin or antidiuretic hormone. Once these neurohormones are made, they are transported down the axons of the hypothalamic hypophyseal tract down to the posterior pituitary, where then the neurohormones are stored in the posterior pituitary. When those hypothalamic neurons fire, action potentials arriving at the hormone terminals cause oxytocin and vasopressin to be released. So these axon terminals release hormones almost like on demand. All right, so moving on to the anterior pituitary gland. This is a true endocrine gland. It manufactures and releases a variety of hormones. It is composed of glandular tissue. Some of the hormones that it releases is growth hormone, thyroid stimulating hormone, adrenocorticopic hormone, follicle stimulating hormone, luteinizing hormone, and prolactin. And a lot of these are produced due to neurons in the hypothalamus that synthesize releasing or inhibiting hormones. So those correlate directly with the ones that the anterior pituitary will release. So some examples of those can be corticotropin releasing hormone, or growth hormone releasing hormone, or growth hormone inhibiting hormone. Those are all synthesized in the hypothalamus. Those hypothalamic hormones are then released into special blood vessels, which are part of the hypophyseal portal system. And those control the release of the anterior pituitary hormones. All right, so the hypothalamus and the anterior pituitary interactions. Neurons in the hypothalamus synthesize inhibiting or releasing hormones. And so when stimulated, these neurons secrete inhibiting or releasing hormones into the primary capillary plexus or capillary bed. This capillary bed is part of that hypophyseal portal system that we talked about earlier. Those hormones then travel through the portal veins from the primary capillary plexus down through the portal veins to the anterior pituitary. The anterior pituitary then secretes the hormones into a secondary capillary plexus or bed, which then empties into the general circulation of the blood.